Hey math friends, it's Bass Action here. We are going to look at the idea of betweenness and how we can apply that to some problems. So when we think about this idea here of betweenness, we generally understand what betweenness means. If I say you're sitting between your two friends, you certainly understand that that means that you have a friend on each side of you. But geometrically, when we think about betweenness, what we really need to think about is the fact that the points when we're talking about them need to be collinear. So that's going to be a really important idea for us. So what we're going to do here first is we're just going to kind of give ourselves a little example of this in a counterexample. So we can see in our description that if A is between B and C, then A, B, and C are collinear. So of course that means that we need to have them on a line. So we're going to give ourselves a line here, and we can give ourselves a couple points. And then of course we want A to be between the other two, so I'm definitely going to put A in the middle, and then I can put my B and my C on either side, and it doesn't matter which side they go on, those could certainly be rearranged. So when we think about counterexamples, when we draw this counterexample, it's important to remember that I can certainly see B and C here and here, but if I put A off the line, now my points are not collinear. So even though visually it feels like A is between B and C, by our definition, it is not. Now, the way we can apply that then is using this segment addition postulate. And the segment addition postulate is a pretty easy concept, and it simply means that if I have a point on a line, I can add the two smaller segments together and get the length of the total segment. So we can look at this in terms of a simple little example. So I'm going to come over here and let's take a look at this statement right here where it says O is between B and G. So when we read this sentence, what we want to really call our attention to here, all right, continuing, sorry about that, as we come over here and we look at our statement here that O is between B and G, we really want to call our attention to this word between, because that's going to indicate to us what our picture should look like. So as we come over here to this picture that I've already pre-drawn for you, we can see that I drew that picture for you to indicate that O is between B and G. You'll also notice that when I drew that picture for you that I intentionally did not put O smack in the middle. I didn't make it look like it was dead center. I kind of shifted a little to one side or the other. So using this idea of the segment addition postulate, we can create this geometric statement here, and I can actually say that BO plus OG, those two small segments, will equal the length of the whole segment together, BG. Now, I'm not going to worry about the reason for right now. We'll come back, we'll hit those in chapter 2, but for right now, this is good enough for us. So if we have this idea of a set point is between, we can add those two together and get the whole. Now, let's take that and actually look at some bigger problems. Looking at our note guides now, on our page 7 of our note guides, I've got a couple scenarios here, and you'll notice I've given you a few prompts. So if I say that H is between C and I, now the first thing that I want to do is I want to draw this as a segment, not a line. So I've got this C and I, and I'm going to put my H on there, and I'm going to make sure that I don't put that H right in the middle, and then I can start labeling my picture. So I can see that CH, it tells me, is 7x plus 13. And it tells me HI is 5x minus 1. And then it tells me that CI, this whole piece, is 3x plus 84. Now, thinking about our geometric statement, what can I do with this? Well, that segment addition postulate says that when I see this kind of a picture, I can add the two smaller segments together and get the whole segment. Once I have that geometric equation, then the next thing that I can do is I can just substitute. CH I can read from my picture is 7x plus 13. HI from my picture is 5x minus 1. And CI from my picture is 3x plus 84. So from here, I've just got some quick little algebra to do. So I've got 12x plus 12 equals my 3x plus 84. Continuing with my solving, I've got a 9x here. Subtract that 12, that's going to give me a 72. So my x is going to be 8. Now, the one other thing that we do want to do is we want to come up here and take a look and look what it asked us to solve for. It wanted us to solve for x, in which case we're done with this problem. So let's do one more. I've got u between h and b. So I'm going to give myself my little segment. I'm never worried about these being to scale. I just need to get an idea of where my parts are supposed to be. So, sorry, that's supposed to be an h and a b. I can put my u on there. So it says that hu is 3x plus 4. And my HB, oh, it gave it to me in a different order this time. Now it gave me the whole piece. And then UB is 42. So you definitely have to read it. You can't assume that they follow a certain order. With our picture, we can say that HU plus UB, the two small pieces, of course, will equal the whole. And then from there, we can substitute 3x plus 4. I can read from my picture plus a 42 equals my whole. Now I just do my algebra. So I've got my 3x plus my 46, my 5x minus 8. In this case, I'm going to choose to move my 3x to the right, so I get a 2x over here. I'm going to add my 8 to the other side. That's going to give me a 54 there. And my x is 27. Now again, I always have to go back and look, what is it asking me to find? It wants me to find the length of HU, which means I'm not quite done yet. The length of HU is going to be 3 times this x value plus my 4. So if I've got a calculator handy, I can even type this into my calculator. My 3 times my 27, of course, is going to be my 81. Plus my 4 is going to give me 85. And I can even put a U on that for units. So there we go. That's how we can apply the segment addition postulate and the idea of betweenness.